Okay, welcome back. Happy Friday. Today is October 7th. It's our 14th class. Today, the next two projects are assigned, projects 3 and 4, about a steel drum and a pipeline. Now, I think a bunch of us grabbed one of each of these on the way out after the test. Is there anybody that doesn't have the two projects? Anybody else? Okay, there you go. So just like before, the two projects are going to be due on consecutive days, not for about 3 weeks. First project is due October 28th, exactly 3 weeks. Okay. In terms of difficulty, both of these projects I would say are sort of aligned with the trucks project for how tough they are. The arbitration one really is the outlier. Okay. Still, you have 3 weeks to work on it, and I'm giving you 3 weeks because I want you doing a little bit at a time, not all of it the day before it's due. All right. Today we talk about how to compose two functions. That'll be a review of pre-calc stuff, and then something called the chain rule. Any questions on the calendar? And just a heads up about today and tomorrow. In fact, you can see the chain rule appearing for both of the next two classes. We're going to talk about a lot of different derivative rules we've already seen, like power rule. We've seen how to add and subtract, and we've got a product rule and a quotient rule, and we've got a constant multiple rule. We're going to see rules for taking derivatives of exponential functions. We're going to see rules for taking derivatives of trig functions, rules for derivatives of log functions, rules for inverse trig functions. We're going to have lots of different derivative rules coming up. The most important derivative rule of the entire semester is the one today. The chain rule is going to allow us to take derivative rules we already know and use them for a much larger collection of functions. Okay? All right, so let's jump in on the top here, actually. So this is the first page of the packet. It is a derivative formulas reference sheet. I'll just point out that we know a couple of these at the moment. The derivative of a constant is derivative 0, right? That's there. The power rule says you take the power down, so it's nx to the n minus 1, which is right there. And there'll be some derivative rules coming up that we'll get to. All right. Here's the important thing for you on the test. You're going to use this on the sheet. You're going to use this on the upcoming tests, both the second test, the third test, and the final exam. All right. So you'll have this reference. In addition to the one sheet you make, you're going to use my sheet. Okay. And on the back of my sheet is a strategy guide for differentiation. We'll talk about that later. Okay. So we're starting on page 3 at the very top. Daily summary. Today, we'll learn a new derivative rule called the chain rule. The chain rule is used to take the derivatives of composite functions. So we'll also briefly review composition of functions. Today, we move into the second third of the course. Make sure to take some time to look over test number 1 and review any questions that you got wrong with a classmate or instructor, Math Studio staff, and or a peer tutor. I'm hoping we don't just look at the grade and then throw it in the binder, never to be looked at again. Turning in the test isn't the last thing I'm hoping we take away from the test. I want us to reflect on what went well and what didn't go well and make appropriate changes to improve in the future. Okay, there's some generic stuff about the project written up in number 2. Essentially, it says continue to work with each other and don't wait until the last minute. Same thing here in 3. And the first page of the projects is the recommended timeline. Okay, so jumping in on number 4. We now present a new derivative rule that allows us to take the derivative of more complicated functions. The chain rule basically says apply the normal derivative rule, then multiply by the derivative of the stuff. So that will have more context in just a moment. At this point in the semester, we don't have a good justification for why the chain rule works. This new thing we're about to do. We're just going to take it on faith. Trust me, it is valid. So let's see if we can apply it. Number 5, let's find derivatives of the following. The idea here is to apply the normal derivative rule and then multiply by the derivative of the stuff. We're going to say that phrase a bunch. Multiply by the derivative of the stuff. I made a slight change to part A. Can you guys cross off x to the 34 and make it x to the 23? Okay, so let's write our derivative. Y prime equals. Okay, this one's easy. What is it? 23x to the 22. No problem. That's an old one for us. We're going to skip ahead to part C, which says y equals x squared minus x plus 1 to the 23rd. if I kind of don't look too closely in here, it's the same as the first problem, right? Like if this thing were just x, I would know how to handle it. So what we're going to do is we're going to pretend that this stuff inside of here is just like the x. Y prime equals. What's the first thing we wrote over there? 23, that's what we're going to write here. Then we copied the x. Well, it's not x. We're going to copy whatever it is. So what are we copying? X squared minus x plus 1. That's the copy the x part. The new power becomes 22. Everything is exactly the same. We see the similarities, right? You just pretend it's x. But then this brand new rule comes in and says, hey, it wasn't just x. And now we have to pay for the fact that we were pretending. And the way that you pay for it is at the very end, you multiply by the derivative of what you pretended was x. This was the thing we were pretending was x. We just multiply by its derivative way out here at the end. What's the derivative of x squared minus x plus 1? 2x minus 1. 2x minus 1. Throw that in parentheses. Okay, so the stuff in purple should be very reasonable. It's the same rule as if it were just x. The stuff in green is the brand new thing that might not be reasonable at all, but trust me, it's the way things work. So we multiply by the derivative of the stuff. The stuff is what used to be x, okay? Let's see if we can try part B here. In order to do B, we first need to rewrite so that this looks like some stuff to a power. What power is it? 1/2. Can you guys try with your neighbors this brand new thing called the chain rule to take that derivative? Okay, let's get our answer up here. What comes down in front? 1/2 comes down. We copy the stuff. 3x plus 1. What's the new power? Negative 1/2. But then the brand new thing says times the derivative of the stuff. What is just times 3. That's it. Last one. You couldn't, yeah, the 3 times 1/2 becomes 3/2. That's about all we can do. All right, questions on that? Okay, so that is the chain rule. Let's come down here to number 6. It says, consider the example in part C above. Below is a very common mistake in using the chain rule. Let's find the mistake and fix it. All right, so starting with the original from part C, x squared minus x minus 1, all to the 23rd. So what comes down in the front? 23, and then what is this? Well, what is that from the original? That's the derivative of the stuff, right? So we put the derivative right in there. New power is?
The original is 2 plus.
Oh, is there a typo in there? Should be a plus 1. Like that?
Yeah.
Okay, thank you. Okay, so we take the derivative of the stuff, put it in there, and then what is this 2 sitting here? Yes, it's a second derivative if you think about it. I mean, it's the derivative of that 2x minus 1, right? And so it's really, really common to make this mistake where you take your derivative of the stuff too early. Like we know that this x squared minus x plus 1 is going to have a derivative taken, but we took it too early. Anytime we do this brand new rule, we have to copy the stuff one time. Every single time we do this rule, you got to copy the stuff once before you get to take the derivative. So we know that we did it right up above. 23 came down. We should have copied that stuff in the parentheses. And then on the outside, the 2x minus 1. Back when I was taking AP Calculus as a high school senior, I don't want to brag, I was pretty good at it back then. But I was studying with a friend of mine who was not as good at it, and we were learning the chain rule together, and it was brand new to both of us. And I had a pretty good handle on what was going on. But my buddy, he couldn't quite get it. He would take a problem like this one that we did up here in part C. And he would get all this right, and he would even get that right there. But then he would say, okay, and then the derivative of 2x is 2, and he would multiply by 2. And sometimes he went really crazy and then said, oh, well, and then times what's the derivative of 2? 0. And so eventually he got to like 0 for every problem because he just kept taking derivatives of the previous stuff. And you can't do that. This isn't like a do it forever. This is just one time take the derivative of the stuff. Just one time. The derivative of x squared minus x plus 1 is right there once and it's done. Okay, so it's always times the derivative of the stuff. Okay. All right. Yeah, so I was better at calculus, but he was better at dunking, so it was kind of like a 50-50. All right, on the next page. All right, so before we jump in on the next page, let's just talk logistical stuff here. All right, so in terms of the test, median grade was 81. That means half of the folks who took the test did higher than 81 and half did lower than 81. None of you is in competition with anybody other than yourself, but I'm sharing this information just so you get a sense of the level of difficulty of this test that you just took. That's the only reason I'm sharing it. High grade was a 99. Okay, like I said, I'm really hoping that people will look at the things that went well and the things that didn't go well and make some adjustments if appropriate heading into the rest of the semester. On the syllabus handed out on the first day of the semester, if you read it carefully, you notice that there's different grading options that you have for this class. Instead of just the one way for me to grade, I want you to tell me how you want me to grade you. I had 3 different options here. My standard one weights the final exam 20%, all 3 tests worth 51% altogether, and all the way down with all the different things. I had a test heavy, I had a test light, and then if you don't like any of those 3 pre-made options, you can pick something as long as you're in the right ranges. I'm going to ask you to commit to one of the options here on our next class, which is Wednesday. Monday is Columbus Day. There are no day classes this coming Monday. There are evening classes Monday, so if you have a Monday night class, you go to that class. So our next class is when I'm going to ask you to commit to this. And I'm going to hand out a piece of paper. I'm not going to do it now, but I'll just show you. Here's a piece of paper. It has each of your names. It has the 3 options here. You can just circle if you want one of those options there, or you can fill in the blanks with the percentages if you're picking your own, okay? Just so that you are prepared to do this on Wednesday. Wednesday during class is not a good time to think about this important decision. You want to come in ready to go, okay? So write your answers someplace so that you have them to fill in on Wednesday, okay? Any questions on that? Okay, so that is that. I think some people came in after I announced, but the 2 next projects are assigned. Is there anybody that doesn't have them yet? Okay, I think most people got them on the day of the test. All right, just a little bit more info in terms of the test. I'm going to say this staring awkwardly at the back wall so nobody thinks I'm talking to them. The last day to withdraw from a class without any record appearing on your transcript is today. I'm not saying that anybody should be dropping the class. I'm just telling you information, this class, any class. Last day to withdraw with no record is today. The last day to withdraw and have a W on your transcript is coming up sometime in November. It's on the green folder. There's some dates there. If you want to know your standing, how I think you are doing in this class, just ask me outside of class. I'm available right after class. I'm available at lunch. I'm available late afternoon. So if you want to talk individually to me about how I think you're doing, come find me individually. Any questions on that? Okay. The reason I stare at the wall again is like I made that speech a few years ago and somebody was like, somebody who was getting an A was like, why are you looking at me? I'm not looking at anybody. So that's the brick wall speech. Okay, so that is that. Good, good, and good. Okay, and if you came in after I gave the test back, I'll give it to you in a little bit. I think that's that. Oh, also so in addition to the new packet today, you should also grab a new homework sheet. Everybody have one of the new homework sheets? So the new homework sheet is a very much trimmed down version of the old homework sheet. Just to give you perspective, this is the one that you've been working off of the whole semester. All these little lines on here are problems that got deleted. No problems got added, only deleted. Some assignments became like a quarter less than they were, some a third, some of them became half of what they were. My colleague Caitlin and I have spent a bunch of time over the last 3 weeks paring down the assignments. That said, again, the goal of everything we do in this class is to understand the material. So if you do an entire homework assignment and you don't feel like you get it, then you should be doing more problems, all right? I can't come up with one assignment that's like exactly the appropriate amount for each of you. That's an individual thing, okay? So make sure you do enough to feel like you get the stuff. But if you're just looking to get full credit on homework, it is a much reduced version, all right? Don't do the problems in the packet, do the ones that are on that page. Okay, I think that is good. All right, so let's come back to here. Number 7, 3 versions of the chain rule that all say the same thing. Version 1 is in English. It says take the derivative of a composition. We should mention that word there. The function we were just looking at was, what was it? X squared minus x plus 1? 23rd? Okay. So if I want to think of this guy as being f of g of x, you guys remember composition of functions, right? Which one goes first, the f or the g? G, inside to outside, right? So g is sort of naturally what part of that original function? X squared minus x plus 1, right? That's the inner function. And then the outer function is what's being applied to this whole thing in the parentheses, and that's just raise this stuff to the 23rd. It's x to the 23rd, right? You don't need to put this x squared business again. It's just take the previous stuff and raise it to the 23rd. Okay, so the chain rule tells you how to take a derivative of a composition. So that's what we've got here. So here it is in English. Not to say it's going to make it any easier to understand, but here it is. To take the derivative of a composition, you take the derivative of the outside function. That was f in this case. What's the derivative of f? 23x to the 22, right? But we didn't write that for the derivative of this original function. It says take the derivative of the outside function, but evaluate it at the inside function. We didn't write 23x to the 22. We evaluated that thing at the inside function, x squared minus x plus 1. And then continuing after the semicolon, then multiply by the derivative of the inside function. Again, the inside function was g for us. Derivative of x squared minus x plus 1 is this 2x minus 1, okay? So hopefully we see the English agrees with what we actually did. All right, 2 ways to think about that same thing symbolically. First, mixed notation. All right, there's your f of g. There's the derivative symbol. F prime of g of x. Do you guys see that that matches the derivative of the outside function? That's the f prime, but evaluated at the inside function of g of x. And then times, multiply, there's the times, by the derivative of the inside function. There's g prime, okay? It's not super important to me that we know that formula today, but we are going to need that formula next class. Because there will be problems where we can't just think about it in English. We just need to know that hardcore formula. Said in sort of a mixed way, the derivative of f of some stuff is f prime of the stuff times the derivative of the stuff. Okay, and then the Leibniz notation, we can take a look at that next class. All right, so here's the plan. The activity is starts on the next page. The activity here is really, really short. Raise your hand if you have the text. If you happen to have the textbook with you here today. Anybody have the textbook? Anybody else have the textbook? Anybody else have the textbook? Yeah. Okay. So we have enough of the textbooks to sort of spread around. So my plan is you're going to do this activity. I think you're going to have lots of time left over in class, and you're going to open up and you're going to start with the brand new homework assignment. Okay. Just practicing chain rule. All right. Raise the flag if I can help.